All right, thanks everybody. So let me first introduce Ampere a little bit. So I'm Jeff Wittich. I'm the Chief Product Officer at Ampere. Ampere, we are a roughly 6-year-old company, and we are a modern semiconductor company that's building something that's very unique. We're building what we call the first cloud-native processors, and the goal is to build processors that can deliver a sustainable cloud. And I'll talk today about how that applies then to sustainable AI as well. Because the time is now to change the trajectory of computing. For the last decade or more, we've been using a set of legacy technologies that were really developed for a different use case, a different era. An era where applications were large and monolithic, where software was not distributed across many, many nodes, a world that was dominated by enterprise applications. Clearly, the world has changed. We're in an era of massive cloud adoption and obviously massive adoption of AI as well. If you look, though, at the impact that this growth in computing has had on the world, on the environment, it's massive. Today, the data center industry consumes about 3% of the world's power. It emits about 3% of the world's greenhouse gases as well. And that's a lot. That's actually more than industries like aviation that we typically think of as being fairly dirty. So we do have a responsibility to ensure that we continue to reduce the share of power that data centers consume. And the only way to do that is by fundamentally changing the trajectory of the compute itself. And not only is the environmental impact incredibly large, but it's also just become really difficult to deploy more and more compute, more and more data centers around the world. Now, some of this is because of those environmental challenges. There's no more power available today. The amount of power we have globally is still roughly the same as it was a decade or two ago, and that poses big constraints. It's not easy to go and build a new data center to procure more power for that data center. In fact, we shouldn't be. We should be living within the footprint. Power costs have also gone up tremendously over the last couple of years. So there's a large operational expense associated with power in the data center. And so that's what we set out to do at Ampere. We built processors that were designed for cloud environments. That's why we call them cloud-native processors. They run cloud-native applications of all types incredibly well. Applications like web servers, databases, caching layers, video encoding, but also AI inferencing. AI inferencing has been one of the very important workloads that we've focused on for the last couple of years. With our processors, we're able to deliver amazing levels of performance, really, really high scalability. Our processors today range from 32 to 192 cores, so a lot of cores to pack into those racks, and they're incredibly efficient. So before I talk a little bit more about how our processors and how some different approaches to inferencing could help us on the sustainability front, let's also just talk about what are we talking about when we refer to inferencing versus training. Now, I'm sure most people in the room are very familiar with this. Training is the act of actually building the model. You train the model, validate it, and then now it's time to deploy. And when you deploy, you're inferencing. And training and inferencing tasks are really different. Training typically is one very, very large task that maybe runs for several months when you look at some of the new multi-hundred billion or even trillion parameter models. So it's one big task, and your priorities might be different when it comes to training versus inferencing. With training, the goal might be to just reduce the time to train. If that costs more money, that takes more power, that might be an acceptable trade-off because time to train is incredibly important. But now when it's time to run inferencing, now you have a different challenge. Now you have a scale challenge. Now you're taking that model that took a long time to train, and now you're running it maybe millions of times a second. And you're probably looking to run it globally. So you need to be able to place that model in various types of compute all around the world in different types of environments. So you have a very different challenge when it comes to inferencing. And so inferencing must be power efficient. It must be cost effective as well. And when you look at the amount of compute required for training versus inferencing, again, training is one big task. So we tend to think of it as all the computes in training. And there is a large amount of concentrated computing happening within training. Inferencing is a lot of smaller compute, but the volume is massive. Various estimates of how large the inference market is versus the training market range from here, it's about 6x, so 85% of the compute deployed for AI is expected to be inference versus training. Other estimates are as much as 10x the amount of compute required for inferencing. But again, a different type of computing task. So there are different trade-offs that you can make. And so one of the trade-offs that we talk a lot to customers about is right-sizing the compute. You look at something like AI training, and maybe there the right solution is some really, really large GPUs that have a lot of memory bandwidth, a lot of parallel compute capabilities. They consume a lot of power, but they achieve your training task in a much lower amount of time. But then as you look at the range of different applications, as you start to get into retraining, as you get into inferencing for large language models, and then inferencing for smaller models, computer vision, recommender models, a different type of compute is often possible to use. At the range of kind of smaller models, computer vision, a CPU-only server is probably the right choice. And that actually extends pretty far out. We've seen really amazing results even up into the 7 to 10 billion parameter models running inferencing on CPUs. And the beauty of using a CPU for inferencing is that they're more efficient, they consume a lot less power, they're more flexible. You can run any workload on a CPU. So when you're done running inferencing, you can also run a web server, run a database. And they're incredibly scalable. You can place these CPUs anywhere around the world. You can place them out at edge locations where you want low latency inferencing to run for, say, safety sensitive applications. So right-sizing your compute is important. You may want really, really big compute for training. When you get into the inferencing space, pick the right amount of compute for the actual model size and for the outcome that you're expecting. And that will help you to reduce your cost and also reduce the overall global footprint from your compute. Just a simple example here as to why we need to explore other approaches and why Scaleway has made other options available to customers than just GPU-based servers. You look at a single DGX system with 8 H100s in it. That can consume about 10.2 kilowatts, just that one server. And if you built a big cluster of those, let's say you had 11,800 DGX systems, that would actually consume 1% of all the renewable power in France. That one cluster of DGX servers. So clearly we're not going to be able to build a ton of these large clusters. We need to use them where they are best suited, and we need to use other more efficient solutions where we're able to. And there's other trends underway too from an AI perspective when it comes to economizing and optimizing. Today we're really in kind of the end of the research phase. We're in the peak of the hype cycle, and we're now getting into the adoption phase. So whereas previously R&D was the priority, peak performance was all that you cared about, throw all compute available at the problem because you just needed to prove out that these large language models were capable of being generated, building huge general models that have really broad knowledge bases. We're starting to transition from that to now focusing on how we scale these in an economical way. How you right-size it, and even the models themselves are starting to change. You will still have really, really large, multi-trillion parameter models, but we're also starting to see the emergence of a lot of more specialized models for various reasons. That could be because of the economics of running a smaller model. It could be because you want to use maybe a proprietary set of data to train that model, and so it's not appropriate to use that proprietary data as part of some sort of large general AI foundational model. And so there's a lot of places here where model sizes are starting to become optimized, and that opens up a really wide range of possibilities in terms of the compute solutions that you can use to run that inferencing. And so at Ampere, like I said, we focused on AI from the start. Our CPUs are incredibly well suited for inferencing, and it's easy for people to use. Great out-of-the-box performance. We have a set of libraries that we call AIO that are publicly available. They're easy to deploy. Under the hood, they do a lot of optimizations around the data itself, and also around, there's a microkernel that helps to improve the performance of the processing itself, but all of that is invisible to the end user. The end user is able to use these software libraries, run any framework that they commonly might be using, PyTorch, TensorFlow, Onyx, run on our CPUs, and get amazing performance. Also, one of the things that people are doing to also economize their models is using lower precision, using FP16 instead of FP32, even using int8 or int16. That's a great way to also economize those models. You're essentially able to reduce the compute overhead by 2 to 4x, and oftentimes there's no real loss in accuracy. And our processors were built to support many, many numerical formats and support those out of the box without any additional work needed on the part of the customer besides quantizing the model itself. And so that's why it's really exciting that today Scaleway announced the new instances available at Scaleway based on the Ampere Ultra family of processors. And these are not only great for general purpose workloads, but really, really good for AI inferencing. They're going to give you the best price performance for most AI models. Just to give you a sense of what that might look like, here are a bunch of different types of models running on our CPUs versus any of the other CPUs that are out there, the Intel, the AMD CPUs. The Ampere performance in terms of inferences per second is in red there, but across whether it's recommender models, computer vision, natural language processing, translation, other transformers, you're going to get the best performance out of an Ampere CPU. And then when you look at it in the cloud, so this is comparing what Ampere looks like in the cloud, say a Scaleway type instance versus all the different options that say AWS might have, which are a lot of Intel instances, Graviton, some GPU attached instances there. As an end user, you're going to get the best performance per euro here. So the most inferences per second per cost per hour. So really, really great economical solution. And you can also feel good about the fact that behind the scenes, it's consuming a lot less power than any of these other solutions. The other thing, too, is just to kind of put it into context, if you look at what a deployment of, say, inferencing on Ampere CPUs looks like versus, say, a bunch of DGX boxes, let's say you had a typical, let's say a 1 megawatt data center. So a little bit on the smaller side. Let's say it has a PUE of about 1.1. You've got 15 kilowatt racks in there. What would the difference be between building it out with Ampere CPUs and with NVIDIA GPUs? Well, with Ampere CPUs, you could deploy about 2,400 servers in that data center. With the NVIDIA DGX boxes, you'd run out of power after you deployed 60 servers. So each rack has a single server in it, so a lot of wasted space. And the cost is a lot less. It costs about $19 million to build out that cluster with Ampere. It costs about $27 million to build it out with those NVIDIA boxes. And the overall inferencing performance is a lot higher with that big scale-out solution with all those servers. You're actually getting here over 4 times more inferencing performance on the Ampere cluster versus the NVIDIA one. The other great thing is that when you're not running inferencing, you can run a lot of other workloads on those 2,400 servers. So you could run over 20 times more, say, web server requests on that Ampere instance cluster than you could with those DGX boxes. So those DGX boxes, when they're not being used, they're just pretty expensive space heaters. When you're not running inferencing on those Ampere servers, you can do useful work across the rest of your cloud. And I just wanted to wrap with a couple of examples of what's happening out in the industry and what Ampere is doing. Lampy is a great example. This is a customer that's actually running on Scaleway now on the Ampere instances. So they're using the Ampere instances for AI inferencing, and they were able to achieve 10 times better speed in terms of performance, and they were able to reduce their costs to only 1/10 of what they were before when they were using x86 processors. So real results being achieved today. And the last thing I'll wrap with is it's not just about Ampere. It's actually all about innovation across the entire industry. A couple of weeks ago, we kicked off a new industry group called the AI Platform Alliance. We have 10 members right now, people like Cerebras, Furiosa, GraphCore, Canara, you can see the names right there. But these are all companies that are building super innovative inference solutions and other AI solutions as well that will be part of an overall solution set that provides you the ability to even more granularly right-size your compute and to deliver amazing efficiency in a bunch of different environments, whether in big data centers or out at the edge. So we strongly believe in fostering this innovation within the industry, and that industry innovation be open, it be efficient, it be sustainable. And so we're going to keep driving the industry in this direction, creating amazing solutions, not just with our Ampere products, but also with all of our partners across the entire market. So with that, thank you. Appreciate the time here, and have a great rest of the day.